Hello guys, welcome to the lecture on infinite series. In the previous lectures, we discussed about infinite series and how to apply the Cauchy's root test and D'Alembert's ratio test, and also we discussed a few problems related to the Cauchy's root test. So now here I am going to discuss about D'Alembert's ratio test. As I told already, so the D'Alembert's ratio test can be applicable for the terms having the factorials like that functions, and it can be applicable for the functions having powers of n also. So now we'll see once again how to apply D'Alembert's ratio test. So D'Alembert's ratio test, if summation un is a series of positive terms and if limit n tends to infinity, un plus 1 by un is equal to L. So where L should be a finite quantity, and then summation un is said to be convergent if L is less than 1, it is divergent if L is greater than 1, and the test is going to fail if L is equal to 1. So now we will discuss few problems related to the D'Alembert's ratio test. So find the nature of series 1 square by 2 plus 2 square by 2 square plus 3 square by 2 cube and so on. So here they have given one series here. The first step is we have to represent this series in terms of an nth term. So I am going to take the equation like summation n from 1 to infinity n square by 2 power n. So here we can observe that if I replace n is equal to 1, I will get 1 square by 2. If I replace n is equal to 2, I will get 2 square by 2 square. If I replace n is equal to 3, I will get 3 square by 2 cube, like that. And here we can observe that for the same function, we can apply the Cauchy's root test also, and also we can apply the D'Alembert's ratio test also. But if the function having the terms like n factorial terms means, for that cases we can able to apply only D'Alembert's ratio test. So now here I am going to discuss this problem in terms of D'Alembert's ratio test. So let me take the function un is equal to n square by 2 power n. So according to the D'Alembert's ratio test, to apply the D'Alembert's ratio test, we should have the function like un plus 1 by un. So further I am going to make un plus 1. Since we have un is equal to n square by 2 power n, so in the same term I am going to replace n is equal to n plus 1. I will get un plus 1 here. So un plus 1 will be n plus 1 whole square divided by 2 power n plus 1. So now make the equation like u power n plus 1 divided by un. So try to cancel all the possible terms. So since here un plus 1 is n plus 1 whole square by 2 power n plus 1 into by un is there here. So I am shifting the all the un term to numerator here. So like 2 power n by n square I can take it. So 2 power n I can cancel. So remaining will be 2 into n square in the denominator. So applying the limit to satisfy the D'Alembert's ratio test, I will get the equation like limit n tends to infinity un plus 1 by un is equal to limit n tends to infinity n plus 1 whole square divided by 2 times of n square. So on expanding the in the numerator, I can take n common factor, since if I apply the limit directly, I will get infinity by infinity form. So the answer is not actually infinity by infinity form. So to satisfy that, I am going to take n common factor from the numerator to cancel the n square in the denominator. So I can cancel n square n square. Now the left out term is limit n tends to infinity 1 plus 1 by n whole square divided by 2. So if I apply the limit here, the 1 by infinity will become 0. The answer will be 1 by 2. 1 by 2 is less than 1. So I can conclude that the D'Alembert's ratio test gives a series is a convergent series. So we'll see one more example on the D'Alembert's ratio test. So test the convergence of 1 plus 2 by 3x plus 2 into 3 into x square by 3 by 5 plus 2 into 3 into 4 by 3 5 7 x cube and so on. So here also we have to make the nth term first. So obviously from the directly we can write un is equal to 2 into 3 into 4 into n plus 1 divided by 3 into 5 into 7 2n plus 1 whole power x power n. I can make it here. So since here x is positive greater than 0, I can make the equation like this. So here it is clear that the denominator and the numerator will be having the function in terms of n factorial only. So it contains the terms of increasing here like 2, 3, 4, and in the denominator also the terms are increasing like 3, 5, 7. So here it is highly impossible to apply the Cauchy's root test. So obviously we should go for the D'Alembert's ratio test. So let me find un plus 1 now. So un plus 1 is equal to 2, 3, 4, n plus 1, n plus 2 divided by 3, 5, 7, 2n plus 1, 2n plus 3. Just I am replacing n is equal to n plus 1, that's it, into x power n plus 1. Now make the equation like un plus 1 divided by un to satisfy the D'Alembert's ratio test. Along with that, limit n tends to infinity. So on rearranging the equation like this, limit n tends to infinity, un plus 1 by un is equal to limit n tends to infinity 2 into 3 into 4 n plus 1 n plus 2 x power n into x divided by 3, 5, 7 2n plus 1 2n plus 3 into numerator is 3, 5, 7 2n plus 1 divided by 2, 3, 4 n plus 1 x power n. So on cancelling the terms, the left out term is limit n tends to infinity n plus 2 by 2n plus 3 into x. So here if I apply the limit, I will get infinity by infinity form. So to avoid that, I am taking n common factor from the numerator and denominator. N gets cancelled. The left out term is limit n tends to infinity 1 plus 2 by n by 2 plus 3 by n into x. So now if I apply the limit, I will get 2 by n will be 0, 3 by n will be 0, answer will be 1 by 2 into x. I got it. So here the term having x term, directly we can't say it is convergent or divergent. So we have to fall into three cases here. The summation un is convergent here if x by 2 is less than 1. That is, if x is less than 2, it will be convergent. Similarly, it is divergent if x by 2 is greater than 1. That is, if the x value is greater than 2, we can say it is an divergent. So test will be fails if x by 2 is equal to 1, or if x is equal to 2, it will be test fails. So we'll see one more example related to the D'Alembert's ratio test. So find the nature of the series summation n from 1 to infinity 4, 7, 10 into 3n plus 1 by n factorial x power n, where x is greater than 0. So it is clear directly, since the terms are increasing and the factorial terms are there, we have to use the D'Alembert's ratio test. So un will be equal to 4, 7, 10, 3n plus 1 into x power n by n factorial. So to apply the D'Alembert's ratio test, we should have un plus 1. So un plus 1 will be 4, 7, 10, 3n plus 1 into 3 times into 3 times of n plus 1 plus 1 into x power n plus 1 by n plus 1 factorial. So apply the D'Alembert's ratio test. So limit n tends to infinity, un plus 1 by un is equal to 4, 7, 10, 3n plus 1, 3n plus 4, x power n into x by n plus 1 factorial into n factorial by 4, 7, 10, 3n plus 1 whole power x power n. So I can cancel 3s plus 1, 3n plus 1 and x power n terms, I can cancel it. Remaining will be 3n plus 4 into x into n factorial. I am going to expand the n plus 1 factorial as n plus 1 into n factorial. So on cancelling the n factorial, the solution will be like limit n tends to infinity 3n plus 4 by n plus 1 into x. I got it. So on applying the limit here, I will get infinity by infinity form, so that I am taking n common factor to make the equation simpler. So on applying the limit, I will get 3x is a solution. So now by D'Alembert's ratio test, we can conclude that summation un is convergent if 3x is less than 1 or x is less than 1 by 3. It is divergent if 3x is greater than 1 or x is greater than 1 by 3. The test will be fail if 3x is equal to 1 or x is equal to 1 by 3. So we'll see one more example on the D'Alembert's ratio test. The test for the convergence of un is equal to x power 2n by n plus 2 into square root of n plus 1. So here also we can observe that it is a complicated equation. So if I apply Cauchy's root test, it will be very complicated to expand the equation. So here also I can use the D'Alembert's ratio test. So let me take un is equal to x power 2n by n plus 2 square root of n plus 1. So un plus 1 will be x power 2 times of n plus 1 by n plus 3 into square root of n plus 2. Just I am replacing n is equal to n plus 1 in the un equation. So now by applying D'Alembert's ratio test, we have un plus 1 by un. So I got x power 2n into x squared by n plus 3 into square root of n plus 2 into n plus 2 into square root of n plus 1 divided by x power 2n. So x power 2n I can cancel here. Remaining will be like I got n plus 2 by n plus the square root of n plus 1 by n plus 2 into x square. Now applying the D'Alembert ratio test by applying limit n tends to infinity on both the sides, I got the equation like limit n tends to infinity un plus 1 by un. So if I apply the limit directly, the answer will become infinity by infinity form. So I'm taking n common factor from each term, I'm cancelling it, and I'm going to apply the limit here. So now the answer will be x square after n tends to infinity. So now here also we'll follow to three cases. So summation un is convergent if x square is less than 1, it is divergent if x square is greater than 1, and test is going to fail if x square is equal to 1. Thank you.